Hello there, Mr. Sutton here, bringing you the Algebra 2 10-3 Part 2 homework solutions on trigonometric functions of any angle. In this one, we will be focusing on finding trig values using reference angles. For the first couple problems, we are being asked to sketch an angle and find the reference angle, which we're calling theta prime. So let's look at 300 degrees here. So this is already in degrees and in standard position. It's between 0 and 360. So I can graph this right away. So 300 is somewhere between 270 and 360, probably closer to the 270 end here. And now to get the reference angle, I just have to subtract this with its closest x-axis angle. In this case, we are closer to the 360 end of things. So 360 minus 300 is going to give me my theta prime, my reference angle. So that's going to be 60 degrees. To find the reference angle on this problem, let me first get this in standard position. It's bigger than 360, so let me subtract 360 to get it a little more manageable. 510 minus 360, let's see, 510 minus 300 would be 210, minus another 60 is 150. So 150 degrees, I can graph that out. That's somewhere between 90 and 180, somewhere over here. Now to get this reference angle, I'm closest to the 180 line here. So to find this acute angle between my terminal ray and my x-axis, I need to do 180 minus 150, which gives me 30 degrees. For the rest of the problems, we're going to be trying to evaluate functions without using any technology, so completely using reference angles, special values, unit circle, all that jazz. So let's start with sine of 150 degrees. This is already in degrees and it's in standard position between 0 and 360. So let me go ahead and actually graph this angle, and that'll give me some insight on what I need to do next. So 150 is somewhere around here near the 180 line. So one thing I want to figure out right away is whether this should be a positive or negative value. Since sine is the y value of the function, y values are positive here above the x-axis, so I know that I'm going to be a positive sine value in quadrant 2. And now I'm going to use reference angles to get this into something a little more manageable. The reference angle for 150, since we're the closest to the 180 here, we're just going to do 180 minus 150. So that'll give us a reference angle of 30. And again, sine is positive over here, so I can rewrite this as positive sine of 30 degrees. Now I know the special value for sine of 30, that is just 1/2. So, and this is positive, so this is just positive 1/2. To figure out the secant of 315, let me go ahead and graph this angle. So we're somewhere between 270 and 360 over here. This is quadrant 4. This is to the right of the y-axis, which is important because secant, if we're figuring out whether this is positive or negative, secant is just the reciprocal of cosine, which is the x value of our angle. So this behaves like an x value in terms of its sign. So that means that secant is going to be positive over here, just like cosine is. So we'll write that down, positive in quadrant 4. So when I rewrite this with a reference angle, it'll be a positive secant of something. Now what's my reference angle? So we're closest to the 360 line. I can do 360 minus 315 to get my reference angle. So that's going to be 45 degrees. And this will be then positive secant of 45 degrees. Now we need to rewrite this in terms of cosine, so I can use a special value. I can write this as 1 over the cosine of 45. And the cosine of 45 is the square root of 2 over 2. So this is a lovely looking fraction here. I'm going to simplify this by multiplying by the reciprocal of this denominator. So I'm multiplying 1 by 2 over radical 2, which just gives me 2 over radical 2. I need to get rid of that radical in the denominator, though, to get simplest radical form. So multiply by root 2 over root 2. That gives me 2 radical 2 over 2, which I can just cancel out the 2's to get radical 2. On this one, we're trying to find cosine of 315 degrees. We've already got degrees and standard position, so I can just go ahead and graph the angle to see what I'm dealing with. 315 is somewhere between 270 and 360, right about here. Now, for figuring out whether this should be a positive or negative thing before I find the reference angle, cosine is the x value of the angle, and that is positive over here to the right of the y-axis. So we know we're going to get a positive answer. The reference angle is just going to be my closest x-axis angle, 360, minus the angle they gave me, 315. So 360 minus 315 is 45. So I can rewrite this as positive cosine of 45 degrees. And I know that cosine of 45 is root 2 over 2. So that's my final answer. On this problem, I'm trying to figure out the cosine of negative 240 degrees. This is in degrees, which is a good start. It is not, however, standard position. It's less than 0. So I'm going to add 360 to give me something that I can put on my unit circle. Negative 240 plus 360 is going to be 120 degrees. So that's the new way of thinking about this angle. Let me go ahead and graph that. 120 is somewhere between 90 and 180, so right about here. And figuring out the positive or negativeness of this, since cosine is x values and we're to the left of the y-axis, that means this is going to be a negative cosine over here in quadrant 2. So when I rewrite this with a reference angle, I'm going to write negative cosine of whatever angle. Now, what is the reference angle? So we're closest to the 180 line I can see here. So I can just do 180 minus the angle to get the reference angle. 180 minus 120 gives me 60. So this is going to be negative cosine of 60. So cosine of 60 by itself is just 1/2. That's one of my special values. So then this becomes negative 1/2. For this problem, we're trying to figure out tan of 2 pi over 3 without a calculator. So I think it would be helpful to start by putting this in degrees so it's a little easier to figure out where we are on the unit circle. So multiplying by 180 over pi, 180 divided by 3 is 60. 2 times 60 gives us 120 degrees. And I'm just going to put that on my unit circle. 120 is right about here. So let me figure out if tan should be positive or negative there, and then I'll get the reference angle to rewrite this thing. So tangent is y over x. Y is positive, but x is negative over here. Since y and x have opposite signs, that means tangent is going to come out negative there in quadrant 2. Or you could think of it as tangent is the slope of the angle, which we can see is negative here. Just two ways of getting to the same conclusion. So let me write my reference angle now. We're closest to the 180 line. 180 minus 120 is going to give me 60. So then this becomes negative tan of 60. Now I need to rewrite this with sine and cosine so I can use my special values. Tan is really sine over cosine, so this is negative sine of 60 over cosine of 60. And I know the individual values here, so making sure I carry this negative through, we're going to have negative root 3 over 2 over 1/2. And now I just need to simplify this. So I can multiply by the reciprocal of this 1/2. So I have radical 3 over 2 times 2 basically. 2's are going to cancel, so this just ends up being radical 3. But I still have this negative here, so this then becomes negative radical 3. In order to figure out cosecant of negative 420 degrees, let me first get it in a form that I can put it on the unit circle to see what we're dealing with. Now this is not in standard position, it's less than 0, and adding 360 wouldn't change that, it would still be less than 0. So I'm going to add 360 twice, which is adding 720. Negative 420 plus 720 would give us 300, so I had to double up on my 360s there. But this I can put on the unit circle. 300 is somewhere between 270 and 360, closer to the 270 end. So to get the reference angle, I'm going to work with the 360 here. But first, let me figure out if this should be positive or negative. Now, cosecant is just the reciprocal of sine. Sine is the y value of the angle. Y values are negative down here because we're below the x-axis. So all of that leads me to believe that this will be a negative cosecant in quadrant, I should say quadrant 4. There we go. Quadrant 4, lower right. All right, so what's my reference angle to go with this thing? 360 is my closest x-axis angle, so 360 minus 300 gives us 60. So then this becomes negative cosecant of 60. And let me rewrite this with sine so that I can use a special value. This is equivalent to negative 1 over sine of 60. Sine of 60 is just root 3 over 2. That's one of my special values. And to simplify this, I need to multiply by the reciprocal. So this becomes negative 2 over radical 3. We're still not quite there yet. Let me multiply by root 3 over root 3 to get the radical out of the denominator. So final answer then will be negative 2 radical 3 over 3. On this problem, we're trying to figure out cotan of 7 pi over 4. Let's begin by getting this in degrees mode so it's easier to figure out where it is on the unit circle. So 180 divided by 4 would be 45. 7 times 45, I just kind of happen to know, is 315, but you could count by 45s if you needed to. So 315 degrees, which is here in quadrant 4 between 270 and 360. So let me figure out if this should be a positive or negative value for cotan down here. Cotan is x over y. The x's are positive down here, but the y's are negative, so that becomes a negative overall result. And the reference angle, we're closest to 360. 360 minus 315 gives me 45, so then this is going to be negative cotan of 45. To make this something I can actually work with, I'm going to turn it into sine and cosine. So this becomes negative cosine of 45 over sine of 45. And I know that cosine and sine of 45 both happen to be radical 2 over 2. So we have negative root 2 over 2 over root 2 over 2. Since I essentially have something divided by itself here, this all just becomes 1. So then we have negative 1 for our final answer. For this one, I'm trying to figure out sine of 4 pi over 3. Let's start by converting this into degrees. So 180 divided by 3 is 60. 4 times 60 is 240. And let me graph that on my unit circle. 240 is somewhere between 180 and 270, right about here. So since we're in quadrant 3 and we are below the x-axis, sine, which is a y value, is going to be negative down here. So negative sine in quadrant 3. Let's get our reference angle. 240 is closer to the 180 side of the x-axis, so I have to subtract 180. 240 minus 180 is going to give me 60, so this is going to be negative sine of 60 degrees. Sine of 60 by itself is root 3 over 2, so then this is negative radical 3 over 2.